Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today, our special guest is Seth Frader-Thompson, and Seth is the president of EnergyHub. And Seth is also in Brooklyn. What's happening in Brooklyn, Seth? Are you having a severe, wonderful day?
I'm having a severely beautiful fall day here in Brooklyn. Yeah, just excited to talk about virtual power plants on one of those days where there's no stress on the grid.
And I think virtual power plants are the coolest thing. A lot of people call them VPPs, and I think it's going to change the world. We just have to get the utilities to catch up with it. And maybe since this is your main business, maybe you could just tell us what a virtual power plant is. It's always good to hear different definitions.
Yeah, I think of a virtual power plant in simple terms as just being a collection of devices, and we can talk about all the different variations of that, but it's a bunch of devices that are typically behind the meter, so owned by customers in people's homes and businesses, and they can be sort of pooled together to control electrical load, or in some cases, put power back into the grid. And if you're a grid operator at a utility or one of the big transmission operators, you can use those in the same way that you would use a power plant. So you can tell them, I need this many megawatts over this period of time. You can ramp them up and down. You can tell them the shape. I think the confusion in the industry, or the sort of disagreement on what exactly the definition is about whether you should peg it to a traditional power plant, which is a very useful thing, but is typically limited only to what it can do for the entire bulk system and not necessarily what it can do for your local power grid. And I think a virtual power plant, because it's distributed, has a lot more ability to do fancy stuff at the local level.
Great. I wonder what would be the smallest battery somebody would hook up to a virtual power plant. I mean, we're not going to have my cell phone while it's charging backfeed the grid, but maybe a 1 kilowatt hour battery.
I don't see why a 1 kilowatt hour would be too small. I think for us, probably the average size of batteries is in the sort of 10 to 20 kilowatt range. That's what like Tesla Powerwalls and some of the big Enphase devices are. We do hear of smaller things. And I actually wouldn't be surprised, honestly, if in the future you have lots of devices. Think about like you plug in your phone. If you wake up at 2 a.m. and you look at your phone, there's a decent chance that your phone says, I'm waiting to finish charging until 6 a.m. for battery health. Why couldn't you use that as part of a virtual power plant?
Sure. Yeah. And feed the grid with your phone battery, right? No, I'm just kidding.
Yeah.
There'd be like microwatt hours or something like that.
Well, if you've got hundreds of millions of them, maybe those microwatt hours will add up.
Yeah, I'm
for
sure
us,
they will.
The big volume in VPPs, it's solar integrated storage, it's electric vehicles, it's smart thermostats, it's commercial HVAC systems. Occasionally you see something more exotic like a Bitcoin mining facility, but it can be basically anything that has significant consumption or generation potential.
That's pretty cool. So are you working with Bitcoin mining facilities? Like what they would do, turn off their miners when electricity got more valuable, I guess?
Yep.
And then they would pay them to turn it off.
And it's a very straightforward equation. If you can pay them more to not run than they would make when they're running, they're happy to do it.
I know I've heard like a lot of people, of course, saying that Bitcoin mining is very energy intensive and bad for the environment. But then I've heard other people say that, well, in certain cases, it makes people build more solar projects because you can have these variable loads that could pay for your solar project. So you, instead of building 1 megawatt, maybe you build 10.
Yeah, I'm not a huge fan of the Bitcoin as a battery argument. I think that argument ultimately becomes like, you can put money into this thing and then it will make more money and then you can spend that money on things that are good for the grid. I don't love that argument, but as a flexible load, it is a very flexible load. And, there are times of day where you have more solar or more wind than you would need. And if you have excess capacity to turn your Bitcoin mine up even higher than it was already running, often that's helpful for the grid.
And that could help people pay for their solar system. So it's a benefit for people making bigger solar systems in some ways, or that's at least an argument that I've heard of. And so virtual power plants, you're saying like 10 kilowatt hour, 20 kilowatt hour. What would be so big where you wouldn't call it a virtual power plant anymore?
I don't think there's a limit to it. If you think about the sort of like quote unquote utility scale solar and storage projects that are directly transmission connected, those are probably not acting as virtual power plants because they're big enough that they are exporting enough real power individually on their own, and they can be integrated into a supply stack by utility that you kind of don't need to call it a virtual power plant. But I have yet
It's just
to
a
see
power
any,
plant, I guess.
it's
Yeah.
just a power plant, right? It's just a renewable power plant. I've yet to see any size asset that's owned by a customer be turned down as part of a VPP, including individual sites that are at the greater than 100 megawatts.
So how does EnergyHub work? So are you like a virtual power plant provider? Is that even what you would call somebody that's in the virtual power plant business?
What we would say is that we sell a software platform that in the utility world is called a DERMS, so a distributed energy resource management system. And you could say that in general, a DERMS is like the tool you use to build and operate VPPs. So the way we work is we get hired by a utility to build and operate their virtual power plants. And then we work with all the companies that are installing solar storage, EVs, thermostats, whatever, to bring those into the platform. And so if you're an end customer, let's say you've got a Tesla Powerwall or an EV, let's say you've got a Nest or Ecobee smart thermostat, you use the app maybe every day to just generally operate that device. Something pops up in that app saying, hey, would you like to get paid to be part of a virtual power plant? And if you say yes, then on the back end of EnergyHub software, you now pop up as part of the VPP for that utility.
So how do people sign up? It's just going to be different in different places and different grids, I guess.
That's right. Our model, we rely heavily on this network of 50 plus partners. So the manufacturers of these DERs, and behind the scenes, we're working with them to put that offer in front of the customer. And so that thing pops up in the app and says, would you like to do this? You say yes. You put in your name, your address. Usually that's it. And you say, okay, I'd like to join. It tells you how much, what the incentive is. So typically you're going to get some sort of a gift card or a check or a bill credit. And it all happens sort of seamlessly within the user experience of the product that you were using.
Do you have any like good success stories of somebody, it could even be yourself, saving a whole bunch of money by using a virtual power plant? And do you even say that, like, do you join a virtual power plant? Do you use the service, or?
I'd say join. We've got lots of examples. I think probably the easiest place to look and the place that folks in the solar and storage industry probably know the best is in the northeastern US, there's a program called Connected Solutions, where if you've got a battery, you can join the VPP and you will get paid something on the order of $250 to $275 per kilowatt of actual sort of average performance over the course of the season. And so people are getting hundreds to thousands of dollars for providing access to their battery. And the way it works is you kind of choose, do I want to rent 50% of my battery to the utility? Do I want to maybe give them 80%, 20%? It's your choice. The utility has the ability to sort of push the button and flex your battery up to 240 hours a year. It tends to concentrate in July and August when they're sort of facing peak demand challenges, but they can, they have some latitude. They pledge not to use it if there's a storm or anytime you would need it for power backup. And we just measure what the actual output of the battery is over the course of the season. Customer gets a bunch of money.
So you get to pick what percentage of your battery you're going to use. Do you have to keep that for a whole year, or can you like change it every hour or every day?
You can change it however you want, and we just average the actual performance. Yep.
Okay, so I could just say like, oh, I don't want to do it right now because I'm doing something else or with my battery. And then tomorrow I want to give you 100%.
Correct. Yep. And you tend to see regionally, there are some preferences. So for example, in Puerto Rico, there's something like 160,000 batteries that are installed on the island of Puerto Rico. That is because the grid was essentially destroyed by Hurricane Maria. And so for reliability reasons, people really need their batteries. And so what you see there is people are generally only giving the utility like 20% of the battery, whereas in places where the grid is super reliable, like in Connecticut or Massachusetts, they might say, go ahead and take 80% most of the time.
Yeah, and if you go on vacation, give you 110%.
Yeah, there you go.
Yeah, okay, great. And so are you working in just certain places or all over the place? And is it only in certain utility areas where you can do this?
It is only in certain utility areas, but that is spreading quite widely. So VPPs in general, we serve about something over 100 utilities. running maybe 120 different VPP programs that are available to at least 60 million homes in the US. Only a subset of those have battery programs specifically. So I'd say maybe there's a dozen. So areas are Massachusetts, Connecticut, New York, Rhode Island, New Hampshire, North Carolina, South Carolina, Arizona. I'm probably forgetting a few, Texas. But these programs are spreading quickly. And so I fully expect that most of our customers will be operating a battery VPP soon.
Great. So how does it work too, where like somebody has a battery and their battery is going to get a signal over the internet to tell it to dispatch?
That's right. Yeah, we are relying on the sort of all the infrastructure provided by the battery manufacturer. So whatever your battery is connected to on the internet, we're not actually talking directly to the battery. We are accessing an API that, again, Tesla or Enphase or others would provide. We hit that API and with a signal that looks like we'd like this battery to output this many kW starting at 2 p.m., ending at 5 p.m., or whatever the signal might be.
Okay.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
And what was that? Did you say it was a something PI? What was it?
Yeah, so an application programming interface. So the idea is that each manufacturer thoughtfully creates a software service that an authorized user like EnergyHub can talk to that basically has certain nouns and verbs associated with it. So it would say, for example, consume energy during these times, export energy during these times, whatever the case may be. They sort of give us a very clear set of commands that we can give it. And then they have a bunch of protection around that to make sure that it's only an authorized user, that we can't accidentally send a signal that they wouldn't want to send, et cetera. And that, I think, just in general gives the customer the sort of confidence and control that only appropriate things are happening with their equipment. And
I would think, too, that the biggest opportunity that you might have, maybe not now, but maybe in the future, would be electric vehicles, especially bidirectional electric vehicles. Are you seeing that happening yet, or when do you expect to see that be the big thing?
We are actually seeing that. So today we run, so the utility industry, people call this V2G, vehicle to grid, but sometimes people also call it vehicle to house or vehicle to everything. So the acronyms are V2G for grid, V to H for house, or V to X for vehicle to everything. And V to X in general, we see huge potential in. You look at a typical like mid-size electric SUV, it's got 5 or 6 times the storage capacity of a typical stationary battery, and it's not being used most of the time. So if that thing is plugged in, you can absolutely tap into it. We have electric school buses participating in some of these programs. We have fleets of old Nissan Leafs that are plugged in, acting like one big kind of mega battery. You can access the Ford F-150 Lightning, a few other vehicles coming soon. So a lot of pretty interesting kind of capability there.
Yeah, I've always thought that the thing with electric vehicles not being able to export and the utilities not wanting them to export, the people that were against it, like the car companies and the utilities, are going to probably be the ones that are more for it as the grid gets more and more renewables on it, like maybe in the next 5 years is just kind of my guess. I do have an old Nissan Leaf. I did go to the Wallbox headquarters over in Barcelona, and I saw they had a fleet of bidirectional electric vehicles. And I guess one of the things that you need too is a special kind of inverter. So it's going to connect up to the DC part of your electric vehicle battery. You're going to have an interconnection agreement, which is a little bit complicated, and the utilities might be not so open to that quite yet. However, they will be soon enough. And I guess there's going to be just certain brands of cars that start letting you do this. And so you mentioned a couple of them. I guess it was the Nissan Leaf and the Ford F-150. And I think I read something about Tesla just having some car that would do that? Do you know anything
Yeah,
about
I believe
that?
the Cybertruck is capable of that. I believe several of the big GM electric trucks are capable. I believe Rivian has said that their trucks are capable. Some of the Hyundais look like they're capable. So I think we're very rapidly approaching that, which I think, like, to your point about interconnection agreement, like the interconnection process is one of those places where a lot of sort of good intentions can go to either die or just be slowed down. And the advent of all these electric vehicles with V2G capability essentially is going to put so much pressure on the interconnection process that utilities will need to streamline it. If you think about like putting solar in, it's a relatively slow process. There's not that many people getting solar. If you think about how many people are buying cars and bringing them home, that needs to be sped up. You mentioned the thing about you need a special inverter. We'd really like it to be that you don't need a special inverter. Ideally, you can use the AC component that's there in the vehicle and the charger to just output directly without a separate stationary inverter, just output AC directly. We are working with manufacturers. We're working with utilities to make all that happen a lot faster.
Yeah, that would be awesome. And I guess what some people are afraid of is that you would just backfeed your dryer plug, or somebody would try to do something like that. And it's not made to backfeed. It doesn't follow all the rules in NEC Article 705 for interconnections. And then you're not following the rules, and it could be dangerous potentially, probably not, but potentially. And so they'll have to figure out how to do that. And I do think that would be the coolest way of doing it. I did talk to a couple of different people from Fermata Energy who are making vehicle to grid chargers, and we could call them car chargers and dischargers, which is our inverters. It goes DC to AC and back and forth, AC to DC. And so when they're making these things, they're going to have like it in a certain place, and it's going to connect to the DC part of your car battery. And I kind of like what you were saying too, is there's already a charger on the car.
Right.
And so you're going AC to DC to charge that battery. It's pretty easy to just flip it around. Mostly it's just going to be software. And then you can all of a sudden go from DC to AC. But then it's like they don't know where you're going to plug it in. Like you might be at your neighbor's house or somebody else's house or some place where there's 100 cars. So they'll have to figure out the solution for that to make it work. Maybe you'll have like something like your charger that comes with your car, and it will be able to do the signal even though the AC to DC part and the DC to AC part is happening inside of your car.
Yeah, I mean, I think what this kind of reveals is like the way the power grid was designed was that utilities assume in general that people consume power, they don't generate. They also assume that any sort of piece of power consuming or generating device is unmanaged, right? That it's just going to do whatever it's going to do regardless of what you'd prefer it to do. And so they design the system to work under any of those conditions. And in return, you can be very confident that when you flip the lights on, the lights go on. But when you have a 70 kilowatt hour, 100 kilowatt hour battery in your car that could dump tens of kilowatts into the grid, you can't go on a passive worst case scenario type planning. You have to say there's a piece of technology there that is babysitting this and that is going to govern what its rules are. But it really flips this like grid planning and operations model on its head to say we're going to rely on that piece of software to make sure that this car doesn't just dump the wrong amount of power into the grid at the wrong time.
Yeah, and I imagine in a future grid where the whole grid is smarter, technology smarter, AI and all that kind of stuff, you're going to go plug your car in at work, you're going to plug it in at all these different places, and it's going to figure it all out. And it's going to do what's best for the grid and what's best for you getting home.
That's right. Yes, that's the right way to think about it.
So you're kind of on the forefront of making all this happen, which I think is very important.
Yeah, it's an interesting time, right? Everything is changing, but we should remember that all of this is happening at the same time that we have just like a ton of pressure on the electricity system, right? For years, EnergyHub and others were focused on making sure that we had enough power available during times of extreme stress. But the confluence of everything that's going on with data centers, AI, reshoring manufacturing, general load growth on the grid it's causing shortages, capacity shortages across the entire power grid. So it is now mainstream news that we're going to hit a point where economic growth is going to be constrained by the amount of power available. And so now everybody is thinking about this problem. And that just means that getting there faster with V2G, getting there faster with general virtual power plants is going to be an accelerator for the entire economy.
Yeah, and I was also talking to my friend Bill Brooks, and he was saying that he had an idea that the inverter that's in your car that turns your wheels could do a whole lot of energy. I mean, if you're thinking about like probably hundreds of kilowatt hours just out of like my car. And so there would also be a potential to use that, but that would be kind of a bit much for any house. It's like it would blow out a 200 amp service.
Right. And it would depend on what time of day you're doing it. And there's a bunch of factors. Yeah.
Yeah. Some neat stuff. So it sounds like there's just like a lot of really fun stuff going on with what you're doing. And how about like, are you seeing more inverter brands, or I should say like bidirectional EV chargers or charger discharger? What's even a good name for that? I guess what they call it in the National Electrical Code is electric vehicle supply equipment, but it could be bidirectional, of course. And do you have, like, if somebody is going to go, I'm going to get a car charger and I want mine to be ready for the future, what should they do?
Yeah, we can work with just about any brand of EV charger. And we use the term EVSE, electric vehicle supply equipment, but I would personally just say chargers. So, Emporia, Wallbox, Tesla, all the major brands we can work with. We also work with
for
all
bidirectional?
Anyone who has a bidirectional product, yes.
I guess that's the question, though, is who has the bidirectional product?
I will say that I'm not sure what's public and what's not, but there's some products that are out there and a lot more that are in the pipeline.
Okay. Well, I can't wait to have all of them be bidirectional capable.
Agreed. Yeah. The other thing that's exciting that we haven't really talked about is just inverter-based resources in general. The inverter on your solar, even if you don't have a battery, can provide services to the grid. And so there's a bunch that the industry can do to make those things talk together in a more intelligent way, make it cheaper and easier to get the stuff interconnected, make it play better with the grid, generally optimize the way the system works.
Great. Well, thanks for what you're doing. Is there any other things, too, that you want to talk about that we did not cover? Yeah.
No, I think if you've got any piece of technology in your house, a smart thermostat, an electric vehicle, battery, solar, and you're interested in joining a VPP, take a look at what your local utility has to offer.
Okay, and should people go to EnergyHub's website to find things out so they can get involved in one of your virtual power plants?
You can go to EnergyHub's website, but generally if you just start by Googling the name of your utility and VPP, or the name of your utility and demand response or smart charging or anything like that, you'll probably find it that way too.
Great. Okay. And how do people find you?
You can find me on LinkedIn. You can find me on EnergyHub's website.
Okay. Well, thank you so much, Seth Frader-Thompson. And thanks for listening to Shawn White's Solar and Energy Storage Podcast. If you want to go learn about virtual power plants too, I have some classes that cover that kind of stuff when we talk about energy storage and solar and all that. So go to SolarSEAN.com and get yourself NABCEP certified. Woo!